All right, I was interrupted with a call, so I guess I'll call this part 2. Hopefully, this won't be too much of a break. So let's go back to this. So the little hat above the RR means that this is an estimated quantity from these data over here. And so now we're saying to ourselves, okay, what's the probability of randomly selecting a study subject who got the disease in the past, who was exposed in the past, but we're looking at it like it's a future thing, you know? So the probability of randomly selecting somebody who got the disease, that would be a yes, given that they were exposed. So now you're only looking at the people who are exposed. So remember, probability is a number over a total, right? So the number who actually got the disease, given that they were exposed, well, that's A over A plus B. All right? And then the probability of giving the disease, that the probability of randomly selecting a study subject who got the disease, given that they were not exposed, well, now you're only looking at the people who were not exposed, and that would be C over C plus D. So this is the relative risk estimate, or R hat, relative risk estimate, given these data. This is what it is. Now, if you want to simplify this a little bit as one fraction, you can do what we've been doing before with the odds. We can take A over A plus B and multiply that by the multiplicative inverse of this whole denominator, which is C plus D over C. Right? So once we do this, we get a nice, ugly-looking expression. It's really not that bad, though. It's A times C plus D over C times A plus B. I mean, maybe it looks a little ugly, but I don't think it's that ugly. So this is the standard formula for relative risk. And if you take a look at that, it should be clear. All right, I was just checking my video camera just to make sure it was actually on. I have to walk over to the other side of the table. Now, let's look at another quantity. I just want to call this quantity X. So let's look at the probability of randomly selecting a study subject who was exposed in the past, given that he or she had the actual disease, divided by the probability of randomly selecting a study subject who was exposed in the past, given that he or she did not have the disease. So again, I'm putting a little bar over the D to represent not having the disease. And if you recall my video that we did on the odds ratio, when we looked at the symmetry of the odds ratio, we saw that when we made this little symmetric switch, we got the same answer. And what I want to, and recall also that this here is a prospective formulation. This is a prospective formulation because given exposure versus not exposure, what's the probability of actually getting the disease? So we're looking at exposure first. The condition always comes first, and then we're looking to see an outcome. So this is what relative risk is, right? Now, I call this X, not relative risk. You probably know it's not going to give the same answer. I call it X, not relative risk, because this has no name. We don't actually use this statistic because it actually doesn't make sense. It doesn't make sense to use this in a retrospective formulation. Let me write that down. So this statistic is not used because it doesn't really make sense. Relative risk is only used in prospective studies, and that should be really memorized carefully. So the prospective formulation with the probabilities is not used, and here's why. Let's just look at this as marbles in a jar, and let's look at the probability. So what I'd like you to do is pause this video, right, and see if you can get the probability of randomly selecting a study subject who was exposed, given that he or she had the disease, divided by the probability of randomly selecting a study subject who was exposed, given that he or she did not have the disease. The retrospective formulation that is never used. But pause the video and see if you can do it. Welcome back. Okay, so the probability of randomly selecting a study subject who was exposed, yes, given that he or she got the disease. Now we're only concerned with the people who got the disease, these A plus C people. So the denominator is A plus C, and the numerator is A, right? Again, the condition fixes our universe. So if we say they got the disease, we're only interested in this column here, these A plus C people. And the probability of randomly selecting a study subject who was exposed, given that they didn't get the disease, right? Now it's B over B plus D. Now pause the video and simplify this the same way you simplified the other one. Welcome back. Okay, so let's do this. So we have A over A plus C times B plus D over B, right? And this gives us A over B times B plus D over A plus C. And I want you to see that these are not equal. And when we use probability, so when we use probability as our measure of likelihood, we see that those two expressions are not equal. When we did that with the odds instead of probability, we saw those two expressions were in fact equal. So the odds ratio is a symmetric measure of association. But relative risk does not have this symmetry. So I'm going to write this. Relative risk is a non-symmetric measure of association and is never used in retrospective studies. Let me make sure that this is fully in the frame. I'm using an iPod. I'm using an iPhone on a tripod to actually do this video, so I just want to make 100% sure I get this well in the frame. Yeah. So if you need to copy this down in a better way, you can pause the video now. Hopefully this part is a little clearer. A little glare, sorry about that. So the take-home message here is that the odds ratio is symmetric and can be used in retrospective studies. It can be used in prospective studies, though rarely is it ever used in prospective studies. And in fact, if you're using this to study for medical board, probably best to say odds ratio is not used in prospective studies, even though there's no statistical reason why you couldn't. But when you have a prospective study, the measure of association of choice is the relative risk, probably because people prefer to think in probabilities rather than odds. And there's some reasons for that being useful, though it could be argued. But that's the culture of our world. So if you like this video, give me a thumbs up and subscribe. If you hated this video and you have some specific suggestions as to what I could do better, shoot me a comment as to what you would like me to do better, and maybe I could even re-record this video doing better. Sorry for having to break it up in 2 parts, but I got a phone call.